Hi, and welcome to video 2 of section 1.1. This is the second of 4 videos. Now, if you've seen the title, you're probably already a little bit worried about this video, or many of you are, because I know that fractions are not everybody's favorite thing. So that's why this is a pretty short video, but I wanted you to have it separately, so if you have to go back and review how do I do different operations with fractions, you'll have quick access to it. So this is properties of fractions. And again, I know fractions are not everybody's favorite thing to have to deal with. I wish I had like a magic wand and could just make it easy for everybody. Unfortunately, I don't. These videos are hopefully the next best thing. But again, all you can do is just practice. And if you do some of the problems in the book and you're still uncomfortable, let me know. I can give you some more examples. I can do supplemental worksheets for you. You can come to office hours if need be. We can do some in class. But I can tell you, if you're taking 126, you're probably going to have to take 127. And for a lot of you, you'll probably have to take 181. And it doesn't end. It's not like this is the one time we have to deal with fractions and then you never have to worry about them again. Unfortunately, it's going to be 3 semesters worth of fraction math for you. So again, if you don't feel comfortable with this, please let me know as early in the semester as you can so that we can make it something that you're comfortable doing. So the first property is multiplication. So let's say I have A over B times C over D. So if you want to think that multiplication is the easiest of your operations, that way when you start having to do other things, it's like, oh, this isn't multiplication, it's not easy. I only say that this is the easiest because the operations we have to do here when we're multiplying 2 fractions, all we're going to do is multiply the numerators by each other and multiply the denominators by each other. So the top is going to be A times C, and the denominator, so top we call numerator, bottom denominator, so B times D will be in the denominator of our fraction as the answer. The second one is division. So if I have A over B divided by some other fraction C over D. This one's not quite as easy as multiplication, but we can turn it into a multiplication problem so then it becomes quote-unquote easy for us. How do we do that? Well, you guys have heard of KFC, the chicken place, right? This isn't KFC, this is KCF. KCF, which is keep, change, flip. So I'm going to keep the first part, A over B. I'm going to change the division sign to a multiplication sign, and then I'm going to flip the last fraction. So instead of C over D, I have D over C. Now what do I have? I have a multiplication problem, which I know is quote-unquote easy. All I have to do is multiply the top, A times D, multiply the bottom, B times C, and I'm done. So on the syllabus, if you've seen any of my other videos, you know, I talk about this quote, that the essence of math is to make complicated things simple, not simple things complicated. So this kind of lends to that point. So we take something that's a little bit tricky to start, but we change it to something that's very straightforward, that's just one operation for it. So if you remember when we have division, keep, change, flip, then it becomes a multiplication problem. We can handle that fairly in a straightforward manner. Where we have to be careful with is addition. If I have A over C plus B over C, when I have addition, I have to be careful that these denominators of each fraction must match, must be the same. So when I have two fractions that I'm adding, if the denominators are the same, what I'm going to do is add the numerators, a plus b, and then the denominator just remains. So it started as c, I'm adding something over c, I end up with something over c. So for example, if I have, whatever, 1/4 plus, I don't know, let's do 1/3 plus 4/3. So the denominator is the same, 3 and 3, so my answer is going to be a 3. Then I just need to add the top, 1 plus 4, so that's 5/3. If it's not the same, then we need to do some multiplication on each of these pieces to find a common denominator. And that's something we can deal with later on here. But as long as the denominators are the same, our fraction is going to end up with the same denominator at the end. If we just have two fractions that have different denominators, so let's say we have a over b plus c over d. So this one now is not quite as straightforward as number 3. They're not the same, so I can't just add the top and leave the bottom. But what we can do, if I have something of this form, my answer is going to be first these two guys, AD, multiply them together, and then BC comes next, and then I use whatever sign here. So if this is a plus, I'll put a plus in the top. If it's a minus, it would have to be a minus. So in this case, it's plus, so that's what's going to go here. And then the denominator is going to be b times d. So if I have just two fractions, I have to add them together. That's the methodology. So let's look at an example here. Let's say I have 2/3 plus 4/5. So unlike number 3, the denominator is not the same. One is 3, one is 5. But using this process, the first thing I'm going to do is multiply the 2 and 5. 2 times 5. Second step is to multiply these guys here. So 4 times 3. Now because this is a plus sign in the original problem, I put a plus sign here. And we can do a subtraction 1 to see, but it's the same process. It's just if this was a minus, that would be a minus. And then the denominator, I multiply these two guys. 3 times 5 is 15. And now it's a matter of simplification. So 2 times 5 is 10, plus 4 times 3 is 12, all over 15. 10 plus 12, 22. So this is 22 over 15, and it doesn't reduce, so that would be our final answer. And again, if this was a minus sign, the only difference would be that this plus would then be a minus, so we'd have 10 minus 12, so we would get negative 2 over 15. That's the only difference. If I have a fraction that has common factors in the numerator and denominator, so let's say I have a times c over b times c. Well, these values c I can cancel in the numerator as long as it's multiplication. If it's addition or subtraction, I can't just cancel from numerator to denominator. But if it's multiplication, as this case is, the c's will cancel out, and this just simplifies to a over b. So again, let's say for an example, if I have, let's see, how about 6/15? And I want to reduce this. Well, 6 is the same as 2 times 3. 15 is the same as 5 times 3. So because I have a 3 in the numerator, I can cancel with the 3 in the denominator, and this just reduces to 2/5. So up until this point, the pieces that we started with, A over B times C over D, or division, or addition, or simplification, there was no equal sign in there until I put equals what the simplified value was. But if I say that if A over B equals C over D, so now there's an actual equal sign in the problem. If I want to simplify this, this is known as what? Cross multiplication. So if you guys had to take like your SATs, ACTs, things like that, you probably encountered this. And so it's just multiply across ways and set them equal to each other. So if A over B is equal to C over D, that means A times D is equal to B times C. So this will come in handy when we're trying to solve different fractions. We can cross multiply, then do some of our basic algebra operations to find the missing values. So let's look at a couple examples utilizing these properties. So the first example, let's say we have subtraction of fractions. So 1/4 minus 1/5. Well, that's what? That's like this guy here, number 4. They're not the same, but we can do the process, which is what? 1 times 5, 4 times 1, but because of this minus sign, we need to put a minus in between these two. And then the denominator is what? 4 times 5. So simplify that, we got what? 5 minus 4 over 4 times 5 is 20. 5 minus 4 is 1 over 20, so 1/20. Sorry if I went a little fast there. Let me step it back here. So 1/4 minus 1/5. First we cross this way, from the top of the first one to the bottom of the second. 1 times 5. Then we do the other way, 4 times 1. Then I have to put in the sign that's between them, so it's a minus here, so I have to put minus here. So this is why the order is so important. I have to do 1 times 5 first, because if I had these switched, what would happen? Down here I would have 4 minus 5, which would have given me a negative value here. So you always have to do this direction first. Do upper left to bottom right first, then whatever's left, and then put in that sign. The denominator, we just multiply the two denominators that we started with, and then simplify from there, so 1 over 20. Second example, a little more complex, kind of using a few different properties. Let's say we have 1/12 divided by 1/8 minus 1/9. So in this case, we have a few things going on, but we need to simplify it as we go. So the first thing we have to do is simplify this denominator. So the numerator, I'm going to leave alone for right now, 1/12. The denominator follows like we just did. So 1 times 9 is 9. 8 times 1 is 8. And then you have this minus sign here all over 9 times 8. So let me just put that here, 9 times 8. Simplify this, we have 1/12 in the numerator. 9 minus 8 is 1. 9 times 8 is 72. So now I have what? I have 1/12 divided by 1 over 72. So let me rewrite that so it looks more like one of our properties. 1 over 12 divided by 1 over 72. So this is what? Not KFC, KCF, keep, change, flip. So 1/12 times 72 over 1. So it's a multiply, we go across 72 all over 12. So now we need to see, can we simplify this thing? And I can. 72 is the same as 6 times 12. And the denominator is what? 12 times 1. So my 12s actually cancel out here. I'm left with 6 over 1, which is just equal to 6. So the first one, 1 over 20. Second one is just equal to 6. That wraps up video 2. It's our fractions, the properties, the different mathematical properties we can use, and then a couple of examples. So if you still need help, review the videos. If that doesn't help, try some of the problems in the book. If you still need more help, let me know. That's what I'm here for. I'm here to help you figure this stuff out. Don't wait until the night before the first midterm or the final and say, man, I still don't know fractions. I wonder if he's awake. Maybe I can call him or email him. Hopefully he's in his office at 2 a.m. I'm not. So learn this stuff now. Don't wait until you don't know it and it starts compounding into other areas of the semester. So that's it, video 2. Come on back and we'll look at video 3.